はい、谷川だけです。
The other challenge here is it's very hard to scale this into larger, especially contiguous regions of the genome. So another approach using hybrid captors is the same technology used for exome sequencing. You put your bait down 2 exons here. This will actually pull down sort of regions of DNA. This is the method we certainly use in my lab to tile across regions that are very difficult to PCR with PCR reactions.
谷川だけです。谷川だけ下り最終工程です。黒西黒ね、最後の下りです。ここでミスったらこける。これも怪我します。まだ軍手使う。軍手が汚れる。ここでよそ見をするといけない。しっかりゆっくり歩いて。トレイルなんか僕できないですよ。危ない。僕はですね、できる人はできる。特別うまいですよ。鏑木剛先生は早稲田の教育学部を卒業しています。剛で気になってるんですけど、うちの父親もアルプスぐらいは出ますからね。うちの父はアルプス、若い頃はアルプスとか登ってたらしいですから。入れるんでしょうか。兄もやってるし、僕もやってる。どこまで行ったかよくわからないですけど。よくわからない。兄は穂高とか行ってますからね。僕は高千穂行ってますけど。関係ないですか。上高地がすごいらしい。唐沢診療所って東大学部のがあるらしい。大和渓谷で知ったと。小山学長を。影響されてるから。足がパンパンかもしれない。下山記念でうどん食いました。上は使いませんでしたけど、音はすごい上の。次は使いましょうかね、ロック上。2000人いるっていうね。帰りはこれっていうのが怖い。で金儲けのためのことだった。まあ、それ以上の効果があるかもしれない。落ち着いて落ち着いて。一番最後が危ないんですよ。焦ってよそ見すると怪我する。落ち着いて落ち着いて早めに帰って。今日はあんまり広い転び方してないですけど、ちょっと転んだかな。その代わり雨で濡れましたけどね。やっぱりあと梅雨遅れもありましたし。でも梅雨トレーニングができて、雨トレーニングができてよかったですよ。 それで分かったのが、もう雨は大したことないっていうのが分かりました。雨は割と標高の低いところで降るっていう。標高の高いところはもう雲の上ですから、あんま雨降らないんです。霧がありますけど、だから雨は大したことないというのが分かりました。あと鎖場もまあ大したことつったら失礼ですけど、最後で危ない。落ち着いて。下山に違う気がする。栗木さんも下山で死んだという。2時半、3時半、4時半、帰り2時間半で終わりました。行きは4時間半かかったので。はい。落ち着いて、ここで気がするんです。はい。まあ、7、8割来ましたから、まあ、そこまで登頂にこだわってない。安全に。はい、終わりました。疲れる。やっと軍手が脱げる。終わった。疲れた。雨降ってる。今日は軍手を3点指示で軍手いっぱい使いましたね。もうやばいですよ、軍手がないとね。死んでましたよね。やっと生きて帰れた。魔の山、マークスの山。海藤さんの海藤武さんのマークスの山って谷川岳じゃなかったですか。だから一番死人が多いって言われてる、谷川岳、どこかしら天神平とかあらへんかもしれない。疲れました。でも無事に、ここが危ないかもしれない。あんま雨降ってないし。パタゴニア、宣伝し。しましょう。はい、無事下山しました。
This is something you stay completely blind to with any sort of sequencing. This is really happening at the regulatory level. It really speaks to the need to read out the functional effects of the genome in addition to essentially the parts that I'm sure you've all seen these types of heat maps before. Essentially, they're just huge colored tables of genes by sample.
谷川岳のいつもちょこっと石拾ってくるんですね。この切り立った石を
zooming in on specific genes that really inform these types. But always know in the back of your mind, the entire matrix is available somewhere. All of those genes have been sequenced, so that data are available, and these heat maps are really just subsets of the overall super matrix. big benefit with providing quantitative data like RNA sequencing is the ability to start to compare your data with other groups. This is something we did in 4 tumors of unknown tissue origin. We just wanted to know where those tumors come from. We knew they weren't necessarily lung primary. In this case, we took all these tumors and we clustered them with a large set of data from healthy tissues. In this case, this is the genotype. Actually, this is the GTEx project, the Genotype Tissue Expression Project, and they're just sequencing tens or hundreds of representations of healthy tissues, or tissues from healthy individuals. And it was actually surprising to us here, these lung tumors actually, specifically with smooth muscle, these were lung tumors actually in women with a hereditary cancer disorder, and we actually think, and almost exclusively in women, we think these are derived from smoothness muscle of the endometrial lining that have been seeding these sarcomas in lung cancer. We can also see how very nicely all the other this is completely unsupervised. I'm going to see all the other tissue types really segregated into not just the tissue, the correct tissue of origin, but actually, in the case of brain, specific components of the brain itself. I talked a little bit earlier about aligning reads not to the human genome reference. This is an example from a lung cancer project we were involved in which we were actually able to completely reassemble the Epstein-Barr.
バンダナが汗を吸い取るって、おでこの汗を吸い取る。ロープウェイです。ロープウェイ、冬には使いましょうかね、冬に。うちの兄がまだ上ってなってますね。妹まだ。
Really, if the DNA or RNA are in the tube, it's in there to be found, assuming you have the right bioinformatics tool to run.
ここの一ノ倉っていうのもいいらしいですね。
Just a couple of new this year. All these concepts we talked about from RNA sequencing are now applicable and doable at the single cell level. So now several commercialized technologies that now will deliver unique cell-specific barcodes in a tube. So essentially you start with this tube of gel beads that contain unique barcodes. This device is 10x
そこから
technology. You basically have these beads come through a microfluidic channel and they get merged with essentially a single cell suspension of your sample of interest. It's actually get merged.
生き返るっていうのは行かなきゃいいっていう話。2本ぐらいこう上川岳トマの耳ベースプラダ
string together. The patient's healthy cell types are also all seated in here, and we also had 2 very, very large populations that are patient-specific. And what you can play this game. You sort of circle out specific cell populations, and you can look up the genes that are being expressed in each single cell. In this case, these are T cells. These are all genes associated with the T cell receptor. In this case, these are macrophages. All the genes expressed, most of the genes expressed with these cells are expressed in macrophages. And same story over here. These are all neutrophils. And these actually turn out to be only seen in the myeloma patient. And one of these is the clonal myeloma cancer cell population. So there's a real opportunity, especially in cancer genomics, to take data from these admixed tumor populations and start to compare those with huge normal reference sets that are emerging, very similar to GTEx. One group that's really leading the way here is the Human Cell Atlas. So their goal is to basically assemble a huge compendium of all single cell data from all tissues, with a big focus on normal tissues. And this is a really incredible reference set specifically for cancer, because now we can take our lung cancers and compare them to thousands of healthy lung tissues, for example. It's also a great funding opportunity. So founders of Facebook, so Mark Zuckerberg's group has now founded a group specifically for funding health initiatives. including the human cell atlas and trainees who want to work specifically in the single-cell genomic space. Okay, so I'm coming up to my last half hour, so I'll just come through some of the hereditary genomics group, and then we'll take maybe a 2-minute break and then talk about the case report at the end. Conceptually, this idea of 2-hit tumor suppressors still holds. I talked about these genes that encode regulators of pathways that are sort of the brakes of the cell. In the case of someone with a hereditary cancer predisposition, they're actually born with one of these loss-of-function variants right from birth. So in this case, here's an example. Here's that same canonical example of 2 chromosomes, but in this case, actually born with a mutation. In this case, they're born with a loss-of-function mutation in the retinoblastoma gene, and essentially now they're only 1 hit away from developing cancer. And really, this idea of multiple types of cancer genome variation acting on the same gene really holds true in the hereditary cancer syndrome space, where there are many different ways where loss of the second remaining functional allele can happen.